Hi guys, in the previous video we figured out how to graphically find the intersection between two lines that are expressed as 2 points, like this. A line through 4, 1, and 8, -3, and a line through -9, -7, and -5, 1. Now I'm going to show you how to do the same thing algebraically. Now, first of all, it's relatively easy to figure out how to find when we know the two equations, because we just set them equal to each other, and we'll do that eventually. But we don't have equations, so our first step is going to be to make equations. So what I'm going to do is find the formula for the line through 4, 1, and 8, -3. Now we've done this in the past, so it's fairly straightforward. We find the slope, we find the intersection, and we know the formula. So I'm going to change the color of my text to light blue to represent the color, not light blue, dark blue, to represent the color of the line in this text. Okay, so I'm going to make that equal, and then we'll do that math in blue. So start by doing y2, right, -3 minus y1, 1. And we'll divide that by x2, 8, minus 4. And that's going to give us -4/4, which equals -1. And that's the slope. Then I need to find the intercept to get the line, the formula for the line. Now we know graphically, oops, didn't mean to do that. We know graphically this guy is going to intercept at 5 from our graph. So it's good to see that this thing is going to match up. Now, if I do it right, now what I'm going to do is pick one of the points. I'm going to use 4, 1 because it's pretty easy, right? So let's use 4, 1, and then I'm going to find the slope, and then I'm going to find the line with slope -1 through 4, 1. So the way I like to do that is I take 1, the y value, equals the slope -1 times the x value. Y equals slope times x, which is 4, plus the intercept, right? Because remember, y equals slope times x plus intercept. Now, I'm going to add 4 to both sides, because I think you all know that -1 times 4 is -4. So if we add 4 to that, it'll cancel, and I'll get 5 equals the, yes I know computer, intercept. And so my formula is going to be, why did I add these parentheses there? It shows I'm a computer person. I always get it. Okay, my formula, so my formula becomes y equals -1 times the slope, not the slope, times x plus 5. So that's my blue line. Y equals -1 times x plus 5. Now I'm going to do the red line. So I'm going to switch my colors so that I'm writing in red. And now we're going to take y2, which is 1, minus y1, -7. So that's going to be 1 minus -7. Thing. And we're going to divide that by, okay, and that's going to be 8. And we're going to divide that by -5 x2 minus x1, which is minus -9, which means -5 plus 9, or 4. And that's going to give me 8 over 4, which is 2. And that's the red slope. And now, once again, I'm going to pick one of these points. Oh, I nearly forgot. On this blue guy, I always like to check my work. How do I check it? Well, I used 4, 1 to get the slope. Alright, what I want to do is plug 8 into this and make sure I get negative 3. So I'm going to do negative 1 times 8 plus 5, and that gives me negative 3, and that means it checks. Now, let's get back to this guy. Okay, I found that 2 was the slope. Sorry about that little interruption. Okay, now I want to find the intercept. So I'm going to pick a point about negative 5, 1. So that's going to give me 1, y equals 2 times minus 5 plus intercept. So what we're going to see is 2 times minus 5 is negative 10, so to cancel it I have to add 10 to both sides. Because remember, you have to do the same thing on both sides. And that's going to give me 11 is the intercept. Which means my formula is going to, the red formula is going to be y equals 2x plus 11. And if we look graphically, we see a check, because if you trace this red line a little further up, it's fairly clear it's going to hit around 11. Another check will be use negative 5, 1. Let's plug in negative 9. So I'm going to take 2 times negative 9 plus 11, and the computer is going to tell me it's negative 7. So that's a check. Okay, I'm not done yet. I'm not even close to done, really, because now I have 2 formulas. Now I want to find what x makes both these y's equal. So I'll go to a neutral color. This one. And I'm going to pick, so I'm going to say, for what value of x is negative 1x plus 5 equal to 2x plus 11. Okay. So, what I'm going to do is try to get all the x's on one side and all the integers on another. The pure numbers. Okay. So what I'm going to do is I'm going to add x to both sides. So that'll get all the x's on the right side. So that's going to give me 5 equals 3x plus 11. Okay, because 2x's plus 1x is 3x. And negative 1x plus an x is 0. Now, I'm going to subtract 11 from both sides. And that's going to give me negative 6 equals 3x. Okay. At this point, I have almost got what x is. I got to divide both sides by 3. That gives me negative 2 equals x. I'm not done yet. Right? So I know what the x value is. Okay? I need to know the y value. Well, I'll try the left equation first. Negative 1x plus 5. So, negative 1, I know negative 2 is x, times negative 2. Don't lose that minus sign. So, negative 1 times minus 2 plus 5 and it's equal to 7. And so that's y. So my point is -2, 7. Is that what I got graphically? Should be. If it's not bad, something bad happened. But there it is, -2, 7. To verify that better, another check is to plug in to 2x plus 11. So we're going to take 2 times, let me put a nice spacing there, minus 2 plus 11. And if I did this right, I also get 7. So that's a nice big check. And that shows that I got my intersection right. So that is the solution to this math problem. So, the same as graphically. If you get different answers algebraically and graphically, you're doing it wrong.